Okay. So, first couple days we've talked about Taylor series, Taylor polynomials specifically, okay? Taylor and Maclaurin polynomials, and we looked at an nth degree. So there's always a finite number of terms, right? This is calculus. We like to push things to the logical extremes. Sometimes so logically extreme that things get really, 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 really weird. This extreme thing is we're going to take that concept of a Taylor polynomial, and we're not interested with a finite number of terms anymore, but we want to extend the concept of a polynomial into a series. That's right. Instead of having 5, 6, 10, 1,000 terms, we're now going to have an infinite number of terms. Now, you've already dealt with series, nothing new here. For instance, if we're looking at 5 to the n over n factorial equals all of those terms, because of the way that this works, each one of these terms, if you notice, once I start expanding my series, each one of these terms is just comprised of constants, right? So that would be considered what's called a series of constants. We like those. All of our series tests require us to have a series of constants in order to decide whether it converges or diverges. What we're going to become more interested in is an infinite series with a variable. If you notice, if I expand this series right here and I start looking at each of those individual terms, yes, the n becomes a constant, but x minus 5 is still x minus 5. And depending on what this turns into, will influence whether my series converges or diverges. So what winds up happening in this problem is we start looking at situations now where we are going to start taking these terms as we expand, and we're going to wind up with this variable. Well, we can't tell if that converges or diverges until we know what x values I want. But maybe that's what I'm trying to figure out. What x values can I use and which x values can I not use? And that's what we're going to be interested in. See, because we're going to find out that this series right here is actually a function. It is actually can be viewed as some function for x, where x is going to have a strict domain based on when does the series converge. Thus enters this really important concept. So what I'm worried about is when does my series converge. Now there are 3 situations where a series will converge. A series is guaranteed, 100%, without a doubt. There is no guesswork here. A series will converge at the center. I really hope so, because at the center we literally say that this function is the same thing, right? So at the center, I'm guaranteed to be convergent. So no matter what I do, I know that I'm convergent at that spot. On the other side of the coin, there may be a situation where I will converge over all real numbers. We'll talk about that one in just a second. Number 2 is the fun one. There's going to be some real number. R is going to be bigger than 0. And we're going to call this R value what's called the radius of convergence. Where if I am less than the radius, if the absolute value of the x minus c is smaller than the radius, then we're going to be a convergent series. And if the x minus c is bigger than the r, we're going to be a divergent series. Now, let's talk about R real fast. I keep using this word radius. What is a radius? It's the distance from a center to the edge. Now, if I'm talking about an x, and x is on the number line, I have a center C, right? So if I have a radius of 5, let's say I'm centered at 2, and I have a radius of, say I have a radius of 2, all right? I have a center of 2, and I have a radius of 2, then what would be my interval that I'd be looking at? 0 to 4, right? I'm going to go from my center, I'm going to subtract 2 from it, and I'm going to add 2 to it. So that's going to be the concept of this radius of convergence. Now the logical extension then is if I wind up with a situation like 1 here, what are we really looking at? That means that my radius of convergence is really, if I only converge at the center, then there's no distance, which means my radius would be 0. Likewise, if I'm looking at number 3, a situation where everything winds up working, well then what would my radius be? It wouldn't be n, It has to be an actual value. I want a radius that will include every single number ever created. What would it be? Go ahead, take it to the extreme. It's got to be infinity. So we're going to have three situations. We're either going to have a 0, we like 0. We're going to have infinity, believe it or not, we like infinity. Or we're going to have a constant. You're going to learn to loathe those moments that we get a constant, even though I think they're really stinking cool. All right? Now how are we going to find R? Well, the funny happenstance is that R actually can fall out of the ratio test. Good stuff. So let's take a look at part A. Write small. There's your warning. Our job is to find the radius of convergence in the interval of convergence. As I stated earlier, we're going to find a radius of convergence by utilizing the ratio test. So if we're thinking about the order that we're going to do this, we're going to go radius of convergence first, and then like Trin, who went, okay, here's my center, my radius plus and my radius minus. That gives me my interval. Then we're going to go ahead and we'll find our interval of convergence. So let's start with a radius of convergence. Ratio test says that we take the limit as n approaches infinity of the ratio of the n plus 1 term compared to the n term, which means we're going to look at negative 1 to the n plus 2, x minus 5 to the n plus 1, over n plus 1 times 2 to the n plus 1, all times n times 2 to the n, or negative 1 to the n plus 1, x minus 5 to the n. Oh, that's gross. All right, I'm going to make our life really easy here for just a second. The negative 1s, I'm inside of an absolute value. What does that mean? Those are just 1s. Cool. Let's start simplifying some of this stuff. Now, I'm going to do something weird. Usually, I do that and I drop the absolute value. I'm going to keep the absolute value here. It's going to be important that we keep the absolute value. You'll see why in just a minute. All right, what can simplify? I'm going to get a 2 in the denominator. 2 to the n plus 1 will cancel out with the 2 to the n. That's good. X minus 5 stays up top. N stays up top. N plus 1 stays in the bottom. So far, so good? All right. Now, here's the next thing I'm going to introduce you to. This limit is looking at what variable? So the limit as n goes to infinity. So x minus 5, is that an interesting piece to this problem at all? X minus 5, if I select a specific x, it's just going to be a constant, right? So I'm going to do something weird here. I want to factor out that x minus 5, but the x minus 5, because it's a constant, it's not the n term. Okay? However, this x minus 5, when I factor it out, what is the x minus 5 inside of? I have to keep the absolute value with it. Now, this is the reason why I couldn't drop the absolute value here. Because what if the x was negative 15? If the x were negative 15, that's suddenly a negative value. And I can't have a negative value in my ratio test. This just becomes n over 2 times n plus 1. Notice I've dropped the absolute value from my limit term now because it's a little bit easier. And we're using the ratio test. When does the ratio... There are 3 outcomes for the ratio test. What are they? There's really 2 important ones that we really pay a lot of attention to. When the ratio is less than 1, our function converges. We want to know when this converges, so let's go ahead and let's set this less than 1. That's an important ratio. All right, can't do anything with the absolute value of x minus 5, but I do know what the limit as n approaches infinity of 2 over 2 times quantity n plus 1 is. That is half. And I can multiply that 1/2 over. Ladies and gentlemen, here's my C. That 2 is my radius of convergence. We're halfway done. Kind of. Now, one thing I do want to point out, real quick, just so we can recall the math. If I say the absolute value of x minus 2 is less than 2, that also means that the absolute value of x minus 5 has to be, that x minus 5 should also be greater than negative 2. We good with that? So do you agree I can rewrite this as negative 2 is less than x minus 5 is less than 2? That looks good, right? And do I really want to pay attention to x minus 5? No. So let's go ahead and let's add 5 to both sides. Negative 2 plus 5. Awesome. 3 is less than, x is less than. Just real quick looking at this. What's the number that's exactly between 3 and 7? It's 5. How far away is 5 from 3? How far away is 5 from 7? One of the things I'm going to tell you, that is such a useful tool. You will eventually get to some questions on the AP test where you'll be given a radius of convergence question. I will guarantee you one of the answer choices you're going to be able to omit just because the center isn't correct or the R is not equal on both sides of your center. So be aware of that, okay? Now, that looks like an interval. But that's not my interval of convergence. See, we said earlier, ratio test says when our ratio is less than 1, our series is convergent. There's another criteria that we hit often. What's the other one? When R is greater than 1, our series diverges. We're forgetting probably the most important criteria of all, though. When R is equal to 1, what do we know about the ratio test? Inconclusive. Ladies and gentlemen, let's talk about interval of convergence. Interval of convergence. When the ratio limit as n approaches infinity of a of n plus 1 over a of n is equal to 1, our test is inconclusive. The key thing here, we must check endpoints. How the heck do you check an endpoint? How do I check x is 3 to see if our function converges or not? Our series converges. The answer is actually pretty simple. We plug it in. Right small, save room. We look at the sum, n equals 1 to infinity, of negative 1 to the n plus 1 times 3 minus 5 to the n over n times 2 to the n. We substitute the 3 into the series, which gives us negative 1 to the n plus 1 times negative 2 to the n over 2 to the n. I forgot the times n there. Do you agree with that? We have some algebra we should probably do. You can call that negative 1 to the n plus 1. I can call this negative 1 to the n times 2 to the n over n times 2 to the n. Now, why would I split that? What happens when I split that? I see some handy-dandy algebra that happens. Yeah. What's up? Cancel some stuff out. What you need, man? Solve that?
No.
Yes, as soon as you divide. Yep. So, now we're here. Can I simplify anything else? Oh, man. By the way, just to give you a heads up, 7's a whole lot easier than 3. Oh, all right. Where are we? What have we got? Negative 1 to the n plus 1 times negative 1 to the n over n. Do you see anything that combines? Because I don't like the way that's written yet. Yeah. Negative 1 to the n plus 1 times negative 1 to the n, we can combine those, add up the exponents, right? This is now negative 1 to the 2n plus 1 over n. And we're almost there. Does my series alternate? Yes? Why do you think that? Check it out. Let n equal 1. If n is equal to 1, this becomes negative 1 to the... Okay, make the n a 2. This is negative 1 to the... Check it out. Think about what these numbers are going to become. 3, 5, 7, 9, 11. Folks, if you start thinking about that, this is always going to be negative 1 to an odd number. What do you know about that? It's an odd number, which means this is negative. So, after way too much stinking work, oh, but thank goodness. Because what can you tell me now that I'm here? Why do you think it's a p-series? Well, okay. Good point. Technically, it's not a p-series because there's a negative, but we're notoriously lazy individuals. We'll just get rid of it. We'll just factor out the constant. We did that way back here, and our constant looked a whole lot worse. And now we are saying that this is a p-series where p is equal to 1. Ladies and gentlemen, all of that work to find out that 3 diverges. Okay, cool. So, what did we find out? We found out that the 3 failed. Failed us. X equals 7. That's right. You've only done half the work. You got to do this a second time. No! This is terrible. Actually, you're going to like this one. I promise. 1, 7 minus 5 to the n, over n times 2 to the n. After far too many variables and far too many things plugging in, we've substituted negative 1, n plus 1, 2 to the n, n times 2. Oh, nice. This is good. This is good stuff. What happened? You got what? We canceled out. Oh my gosh. Sweet. There's no stupid negatives to have to deal with. I love it. I hate the negatives. Actually, there's a negative, but it's okay. This is good. There's no weird, freaky negative thing going on. Will this alternate? Armando's going, hold on. Let me look at these now. Yeah. Ooh. Wait, if it alternates, what series am I looking at? What am I really hoping? I'm hoping for an alternating series. What are my conditions for alternating series? Condition 1. We have to be alternating. A of n alternates. Condition number 2. What on earth does that mean? Well, that's the third condition. But what is decrease in magnitude? Yeah, it means that the next term, if we ignore the negative, each term gets a little smaller, so alternates, decreases in magnitude, and you were alluding to my final one. How do we say that mathematically? The what approaches zero? Yeah, we're looking at a limit as n approaches infinity equals 0. What does that say? Converge by alternating series test. Okay, you ready for the really depressing part? All of this work? It's time to write the answer. I promise that this is the only bad one we do in class. There's a couple of these in the homework. All right, we were asked to find two things. We're asked to find a radius of convergence, and we were asked to find an interval of convergence. So I guess I'll do it this way. What was the radius? 2. That was way back here, like 18 years ago. What is my interval going to be? What is the interval? All of this work. Should be 2 finite values. So if the radius is 2, and my center was, what was my center here? Be 5. My radius is 2 and my center of 5. What are my two numbers I'm between? 3 and 7. All of that work, right? Do I have to include any of these? Why? All of that work. So you can put one line. But what this winds up doing, folks, is we can now look at this particular function, this series, and as we look at this series, I know if I ever get a number, if I get the number 8, there's no point in even looking at this series at 8. Why? Because at that point in time, I've told you that the series is not going to equal the function. And this is going to play a really large role. I know that right now we're in a bunch of really theoretical stuff. The application starts tomorrow. That's when the real meat and potatoes of all of this really comes in. Okay. Notice that B and C are significantly smaller than A. You don't have to write as small. Yes, you need to go. All right. So now let's take a look at B. Everything starts the same exact way for radius and interval of convergence. We look at the ratio test. Ooh. X to the what? Oh, fine, get it right. How'd you get that? Huh? Bring it. There you go. Recall that this is actually going to be 2 times n plus 1 plus 1. So you would distribute the 2. Oh my goodness. And then we write way too much stuff to say that we're only setting up a problem. By the way, where's this centered? Where is my series centered? Why? Not saying you're wrong. Just if it's at 0, what would be a good reason for our center to be 0? And part of the reason why I ask this is that if we know where the center is and we have a radius, like I said earlier, if I know what the radius and I know what my center is, that really makes some of my problems a whole lot easier to start addressing when I go through this. Why is the center at 0? Yeah. This isn't x minus x plus anything. This is just x. All right. Taking a look at this, this is going to start getting pretty gross pretty fast. We've got the limit as n approaches infinity. I saw a few people were already starting to simplify their problem down. So the negative ones, I'm cool with canceling those out. Constants, we're happy with those. We can't cancel out the x's because they might be negative, they might not. What does this simplify down to? This is a tougher one to simplify. That's better. Let's practice rewriting our factorial. How could I rewrite my 2n plus 3 factorial? It would be 2n plus 3 times what? 2n plus 2. All right, well, that doesn't cancel anything out yet, does it? So in our denominator, we're left with 2n plus 3, 2n plus 2, and x to the 2n plus 3 over x to the 2n plus 1. Ugh. We could always split this, call that x to the 2n times x to the 3, and I can call this x to the 2n times x to the 1. If I do that, would that reduce anything down? Yeah. All right, so now what do I have? I have the absolute value of x squared, limit as n approaches infinity. I should probably use that. 1 over 2n plus 3 times 2n plus 2 should be less than 1. Now we evaluate the limit, which is what? It's good stuff. It's good stuff. What is it? It's a 0. So now what do we have? We have the absolute value of x squared times 0 is less than 1. I got two options here. I can look at this one of two different ways. I'm going to do both methods here. One of the things I can look at is I could say that x squared times 0 is definitely doesn't matter what x value I use here. Yes, sir. But we're inside an. Yep. It's okay. I've been there. I've done that. And one of the things I hate doing is putting the -1 in there just because I know what's going to happen to it. I know it's going to go away, but I get terrified that the evil test graders are going to do all sorts of terrible, horrible things to me. So I still write it. So I have an option. I can either look at this as 0 is less than 1. Or I can look at this as this. I can divide by the 0, and I can say that the absolute value of x squared must be less than what's 1 divided by 0? Now, two schools of thought. Both of them will get to the same conclusion. In this conclusion, this one tells us what my r is. This tells me that my radius has to be infinity. In this one tells me that it doesn't matter which x value I choose. If I pick a really huge number, does it matter if I multiply it by 0? No. So in this problem, what it's really giving me is my interval, which in this case, if I can pick any number, what do I call that? Or negative infinity to infinity. Now what winds up happening with this is if I have an all real numbers interval, how far out can I go? Infinity. Or if I have a radius of infinity, which numbers do I include? All of them. Which one are you? That's your choice. Groovy? All right. Last one. We're almost there. Last limit, folks. Limit as n approaches infinity of n plus 1 factorial times x minus 3 to the n plus 1 all over n factorial times x minus 3 to the n. Oh, there's no negative ones to cancel. All right, I'm going to skip a step into here. I realize that I'm going to be left with an absolute value of x minus 3. You all good with that? And you can actually skip to that step. That's fine. Limit as n approaches infinity of what? So these are gone. Now I've got x plus 1 factorial over n factorial. I want that to be less than 1. So I have the absolute value of x minus 3. What is the limit as n approaches infinity of n plus 1? Again, two schools of thought here. School of thought number 1. I can divide by the infinity. What's 1 divided by something stupidly big? So one of the things I can say is the absolute value of x minus 3 is less than 0, which implies that my radius of convergence is 0. Another way I can look at this is what's the only way to make a large number be less than 1? I'd have to multiply the large number by a 0. What's the only way I can make x minus 3 be 0? Which should make sense because, again, if I have a radius of 0, can I go outside of my center? I'm stuck, right? Ladies and gentlemen, radius of convergence. It's a lot of work, and I'd love to tell you that this does not show up on the AP test. It's pretty much guaranteed to be there. It's good stuff. It's got a lot of fun math in there. We will go from there. It's good stuff, and got an assignment that goes with this. It'll be fun.